Today I'll be dealing with differentiation. When we talk about differentiation, there are some certain things you need to understand as a student. Without that, you will not be able to go further in that particular topic. And the first thing is the general formula. What is the general formula for differentiation? Let's assume the question is y equals to x raised to power n. To get the differentiation of this, that is the y in respect to x, that is going to be the power multiplied by the coefficient of x here. And what is the coefficient of x? 1. That will be n times 1, which is n. Then x, you subtract 1 from the power as well. N is power minus 1. That's nx is power n minus 1. So, what am I saying? Let's assume they say y equals to a raised power n. This differentiation is going to be dy over dA. It will no longer be dy over dx because the letter on the right hand side that you are differentiating with is letter A. I hope you understand that. So now, the general formula is what? Y nx raised power what? N minus 1. Let's treat some examples. Example 1 is, if y equals to x squared, what is dy dx? Definitely you know it was 2x. That is 2 times the coefficient of x, which is 1. Then you subtract 1 from the power. That's 2x raised to power 2 minus 1, which is 1. Then 2x raised to power 1 is what? 2x. That is that. Let's take another example. Let's assume we are being asked to differentiate this minus x raised to power 3. This is how you differentiate this. Dy over dx is going to be what? The power is what? Minus 2. You use it to multiply the coefficient of x, which is 3. That will be minus 2 times 3. That's minus 6. Then x raised to power, you subtract 1 from the power, which means minus 2 minus 1. Minus 2 minus 1 is what? Minus 3. Majority of the students actually tend to what? To think minus 2 minus 1 is minus 1. But no. You are only 2 and you are still using 1. That makes it minus 3. So that is for this. Then minus, what is the coefficient of x here? 1. Then you use the power to multiply the coefficient, which is 3 times 1, 3. That will be 3x, subtract 1 from the power, this power 2. I hope you understand that. Moving on, the next thing is function of function. And the formula for function of function is, okay, this is function of function. The formula for function of function is dy over dx is equals to du over dx times dy over du. If you look at it, the du can cancel du. At the end of the day, we have what? Dy over dx. But that is not where we are going to. Let's take an example. An example says, if y equals to 3x squared plus x raised to power 3 all raised to power 4, differentiate this. Now take note, you can be asked to find the dy over dx. It's still the same thing as finding y prime or first principle. When they say first principle, that is for those doing theory. That's what you're writing. There is a formula for this. But when they say find y prime or find dy over dx, it means you are differentiating. Or find y in respect to x. Find y in respect to x. It's still dy over dx. So moving on, you need to say because this particular question means that we have different functions. What do I mean by different functions? You can rewrite 3x squared plus x raised to power 3 in 4 places. That is like you having 4 functions. But function of function has made it easier by saying let u equals to the one enclosed inside the bracket, which is this, plus x raised to power 3. So if you find du du irrespect to what? Dx. You have what? 6x, don't forget, plus what? 3x squared. I'm sure you know how to differentiate like that. So, since you already said, let u be this, let u be what is inside there, it means automatically your y will be what? U raised to power 4. Everything here will be automatically u, then the power 4. Then you now look for the y over what? Du. That's y irrespect to u, which is what? 4u raised to power what? 3. So, not forgetting the formula, dy over dx equals to what? Du over dx times dy over du. What is du over dx? Is what? 6x plus 3x squared. Then times, what is the dy over du? This is du over dx. Then dy over du will be what? 4u raised to power 3. So at the end of the day, you have something like 4u raised to power 3 into bracket of 6x plus 3x squared. But you are not done yet. Why? What do I mean? You already said let u be something. So you now come back to where you said let u be something and replace back that something back to the former to its normal position, which is 4 into what is the representation? That's 3x squared plus x raised to power 3. Then 6x plus 3x squared. So that's it. This is your final answer. Another thing, let's do something else. Another example on this. Let's say y equals to x squared minus 5x plus 6 all this power 4. I'm using for you. Let me use all this power 7. So what you need to do what? Is what? Let. This is how you know function or function. You only have a particular function enclosed in brackets, then raised power something. That is function or function. That's function or function. So you say let u equals to what? What is inside? X squared minus what? 5x plus 6. Du over dx is what? 2x minus 5. Anytime you have 5x, or anytime you have a number that is raising to power 1, the final answer is going to be the number. What do I mean by that? You know, 5x is like saying 5x is power 1. So at the end of the day, 1 times coefficient of x is what? 5. Then x is power what? 1 minus 1. 1 minus 1 is what? 0. That's x is power 0. So 5x is power 0 means what? X is power 0 is 1. Then 1 times 5. 5. But when you differentiate a constant is a number that has no letter. It is always going to be 0. But do you know that that number actually has letter? We can say 6 is 6x is power 0. What is x is power 0? 1. Then 6 times 1 is 6. But many will be like, but 6x is power 0 means x is with 6. No. If x is with 6, that means 6x always power 0. This will automatically mean 1. So moving on, we've gotten the du over dx. So don't forget that we already said let u be this. Automatically our y will be what? U raised to power 7. That is what? Dy over du equals to what? 7 u raised to power 6. At the end of the day, don't forget dy over dx will be this multiplying this. That will be 7 u raised to power 6 times 2x minus 5. At the end of the day, you replace back your u, which is 7 into what? X squared minus 5x plus 6. All is power 6 into 2x minus 5. In differentiation, there is no always need to expand, because if you are trying to expand this in 6 places, it is going to be a time waste. But once you don't see this arrangement in your options, interchange it. Bring this one here, change this one here. You always see one. So that is that and that. This is function of products. When you say function of products, it means you have 2 to 3 functions. You have 2 to 3 functions. An example is like you say 2 into 3 into Majorly I will be diving into two functions alone. What do I mean by that? Example. X. Let's say y equals to s plus 5. Then 3s4 minus 5 minus 6x. Let's see something like this. In this aspect, you see that we have two functions, function 1 and function 2. Say this one be u, this one be u. Indirectly, they are saying let u equals to this, let u. I'm not trying to write it, but I'm trying to let you know that our u is this, our v is what? This. That is two functions. So to find the u over the what? The u in respect to what? X is going to what? 2x plus what? Plus 0. 2x plus 0 is what? 2x. Then the next one is what? Dv over dx, which is what? 12x raised to power 3 minus what? Minus 6. At the end of the day, your formula is what? Dy over dx equals to what? Do let me write it. Okay, let me write it out. U dv over dx plus v du over dx. What is our u? S squared. Always include your stuff inside the bracket. And what is our dv dx? Dv dx, this. That is 12x raised to power 3 minus what? 6. Plus, what is our v? Our v is what? 3x raised to power 4 minus 6x. And what is our du dx? Is 2x. The only thing you can do here, don't bother yourself expanding this. And if you like, you can choose to expand. You can actually expand. But you can also expand plus this one. 2x times this is going to what? 6x raised to power 5 minus what? 12x squared. Let's move to the next thing. Function of quotient. Dy over dx equals to v du over dx minus u dv over dx all over v squared. You will see that all these things are kind of interwoven. This one is leading to this. Function of quotient, don't forget this. U dv over dx plus what? V dv over dx. And in some textbook, it can be v dv over dx plus what? U dv over dx. If you do notice, you will see that it is plus plus. But in this function of quotient, your v is positive while your u is negative. That is u minus u dv over dx all over this. What do you mean by function of quotient? Function of quotient is just like saying division. Two functions, the division of two functions. How do I know? X squared minus 5x. I'm always using this example. All over x squared equals 2x squared 6. This is function of quotient. You say let this be u, let this be v. You can decide to say let u be this, write it out, but I have actually indicated it that this is my u. So my du over dx will be what? You differentiate this, which is what? 2x minus 5. Then my dv over dx is what? 2x plus 12x raised to power 5. I think you understand. 2x plus 12x raised to power 5. So at the end of the day, inputting it into the formula, that will be what is our v? Our v is this, which is that's our dy over dx equals to what? What's our v? Our v is x squared plus 2x raised to power 6. What is our du dx? 2x minus 5. Then minus, what is our u? Don't forget, you open a big bracket first before you start this. What is our u? Our u is what? X squared minus 5x minus 6. And what is our dv dx is what? 2x plus 12x raised to power 5. Close the bracket, close the big bracket. All over is long, right? Yes, it will always be long. All over v squared. That is this v. S squared plus 2x power 6 squared. So if you have time, you can expand. Because in most cases, you cannot always see the answer. So you is that of the function of quotient. I won't want to dive into other questions of that. But the next thing I will be doing is trigonometry function. That's 3. This is tan 2x. This is how you will solve it. Let u equals to 2x. Then your y will be what? Tan u. This is function of function. This is function of. Do you understand this? What is now du over dx is 2. Me as a person, I know what the answer will be. I know it will be 2 sec something. And what is your dy over du? What is tan u? Tan u still the same thing as tan x is sec what? Sec square x. But it will not be sec square x here, it will be sec square what? Sec square u. Sec square u. Because we said dy over du, like I told you, when you differentiate, it is the letter that is on the other side that will be the one that will be the whatever. So at the end of the day, you now use formula of dy over dx, this function of function. Dy, anyhow, let's say du over dx times dy over du. That was du over dx is what? 2 times what? What's dy over du? Sec square u. That's what? 2 sec square u. But you're not done. Don't forget I told you, when you're dealing with function of function, what is now u? This is it. That will be 2 sec square 2x. That will be the final answer. What am I trying to say? What I'm trying to say is, if you have a question like cos 3x and you're being asked to look for the differentiation, that should be minus 3 sine 3x. Very simple. Why do I have minus? The minus is because the differentiation of cos x is what? Minus sine x. So I have the minus. Then the 3 will come out, then sine 3x. As simple as it is. What if they say sine 5x? That was 5 cos 5x. As simple as ABC. I think that's all. Then moving to the last one, that's question 4. That's question 4. Question 4 is why this? So let's solve it. Dy over dx. What kind of formula are we to use? This is the quotient function. That is u over v. So you use what? V du. You use v du over dx minus u dv over dx. All over what? V squared. What is our u? This is our u. This is our v. So what is du over dx? If you differentiate this one is going to be 3 cos x. 3 cos x. Why the dv over dx? What is cosec x? Is what? Minus cosec x cos x. So at the end of the day, these are the things, this, and this will be what you put here. So your dy over dx will now be what? What's your v? Cosec x. What is your du over dx? 3 cos x minus, like I said, you open a big bracket first before you start the next one. What is your u? 3 sine x. And what is your dv dx? You see how long it is? Cosec s cos x. So at the end of the day, all over what? What's v square? That is cosec x squared. So at the end of the day, you have something like 3 cos x cosec x. Anyhow, this one will come to what? Plus 3 sine x cos x cosec x. Is that not it? All over cosec square x. But I can see something common in this numerator and denominator, you will realize that your cosec x are both common. Why not factorize it out? That's cosec x into what? 3 cos x plus 3 sin x cos x all over cosec square x means cosec square x means cosec x in two places. Is that not it? So this will cancel this. Your final answer will now be what? 3 cos x plus 3 sin x cos x all over what? Cosec square cosec x. So this will be your final answer. Even if you want to continue, you can still continue, but we don't need it here. If you want to continue, you can actually continue. So this will be the video I will be doing regarding differentiation. So try and make more of your
Oh no, exams are approaching and I need to understand some topics.
I was making mention of first principle. There is also second principle. What do they mean by second principle? Let's say y equals to x squared. Y prime, that's differentiation. The first differentiation is the first principle. That's 3x squared. We have the second differentiation. That is y prime prime. Which means you are differentiating the original one twice. That's the meaning of second principle. That will be 6x. You are differentiating this. That's the meaning. But you cannot get second principle without getting first principle first. What do I mean by that too? You see that in your manual. You always say something like the square y all over the x square. The square y all over the x square means first and second principle. It means second principle of y irrespective of x. It means you will differentiate that y first. You will not still differentiate it again. That's when you have the square y all over the x square. So if you have